Here we are back looking at example 3 from chapter 23b. We are looking at, we need to show that the following are probability distribution functions. So what do we need to do to show that? Remember, show that questions are, we start with the information they give us. We have to be able to work with it mathematically until we end up with what they want us to show. What they want us to show in this case is that it actually is a probability distribution. So what are the two rules that define that? We need to remember every probability has to be between 0 and 1, and all of the probabilities have to add up to 1. So same two rules we're used to dealing with simple probabilities and now with probability distributions. So number A says it defines the probability distribution as P of x is equal to x squared plus 1 all over 34, where x is only equal to 1, 2, 3, or 4. So we take a look at this and we actually just figure this out. Let's figure out the distribution. What is the probability that x is equal to 1? Well, that will happen when x actually is equal to 1. So substitute 1 in for x into the function. 1 squared plus 1, which is 2 over 34. Okay, I'll just leave it like that because it'll be easier to add up if they're all over the same fraction. Okay, what's the probability that x is equal to 2? 2 squared plus 1 all over 34. So 5 over 34. All right, what's the probability that x is equal to 3? 3 squared plus 1 all over 34. So that's 10 over 34. And last one, what's the probability that x is equal to 4? Again, substitute 4 in to the function where x was. And that would be 17 over 34. Now, does it follow the two rules? Is each probability in between 0 and 1? So there's 1, there's 1, there's 1, there's 1. Yes, all of them are in between 0 and 1. So each probability is between 0 and 1. And do they all add up to 1? So 2 over 34 plus 5 over 34 plus 10 over 34 plus 17 over 34 equals 34 over 34, which equals 1. Therefore, yes, it is a probability distribution function. Part B. Now our probability distribution is being defined as P of x is equal to 3 choose x. Now remember, this is you can work this out with Pascal's triangle, or you can use your calculator and choose r. Okay, so 3 choose x. 0.6 to the power of x times 0.4 to the power of 3 minus x. And the only possibilities for x are 0, 1, 2, and 3. So again, let's figure out each of these situations. The probability that x is 0. Fill in 0 wherever there's an x in the function. So 3 choose 0. 0.6 to the power of 0. 0.4 to the power of 3 minus 0. 3, anything choose 0 as 1. You can check it on your calculator or draw the Pascal's triangle if you want to remember. Let's recall. This top number means what row we're working with, and the bottom number represents the sequence, the position in that row. Okay, so in this case, here's Pascal's triangle. Third row, 0 position, that equals 1. So anything choose 0 is equal to 1. So that's 1. 0.6 to the power of 0. Anything to the power of 0 is also 1. This is 0.4 to the power of 3. So we could do 0.4 times 0.4 times 0.4, or 0.4 to the power of 3, which is 0.064. Okay, let's get rid of this here for a minute. Probability that x is equal to 1. fill in 1 wherever there's an x. So 3 subtract 1, that's going to give us 2. Anything subtract 1 as itself, so 3 choose 1 is 3. 0.6, the power of 1 is 0.6, and 0.4 squared is 0.16, I believe. Let's just check that. Yes, and then we add those out, no, we multiply that. We get 0.288. Double check, make sure I entered that correctly. Yes. Okay, next one, probability that x is equal to 2. 3 choose 2 from our Pascal's triangle, that is equal to 3. 0.6 squared and 0.4. 3 subtract 2, that's going to be the power of 1. So 0.6 squared is 0.36, and that's the power of 1, so 0.4. Multiply that. Uh, 0.432, 0.432. And the last one, probability that x is equal to 3. 3 choose 3. Anything choose itself is also equal to 1. 0.6, power of 3, 0.4, power of 3 subtract 3, so that's 0. So 3 choose 3 is 1, 0.6 the power of 3, 0.4 to the power of 0 is also 1. So 0.6 to the power of 3. 0.216. All right, so now we have to check our 2 rules. Are each of these probabilities in between 0 and 1? This one, this one, this one, and this one? Yes, they're all in between 0 and 1. And do they all add up to 1? So let's show that work. Uh, 12 and 8 is 20. 16, 17, 18, 20. 4, 8, 10. And the decimal. So yes, that adds up to 1. You could do this in your calculator instead if you want, but it adds up to 1, so therefore, yes, this is also a probability distribution function.